Hi everyone. In today's lesson from Unit 3.1, we're going to be learning about the tangent ratio. The tangent ratio is part of a part of mathematics called trigonometry. And trigonometry is the study of triangles and the relationships between their sides and angles. We're going to focus on right triangles. And in a right triangle, there are two acute angles. For each angle, there is a leg of the triangle that is opposite the angle and a leg that is adjacent to the angle. Remember that adjacent means that it's right next to the angle. In the case of an angle, the adjacent side is one of the sides that helps to form the angle. So if you take a look at our picture, and I've marked an arc at angle A right here in the lower right hand corner, and if you look all the way across the triangle, that side is called the opposite leg. And if you look at the side that helps to form angle A, that's our adjacent leg. Now, you might say, well, what about this side over here? Well, recall that this side that I just highlighted in red is called the hypotenuse. So it's not a leg of the triangle. The legs are the two sides that make up the right angle. So we're going to leave the hypotenuse out of what we're discussing today. We don't need it. So the ratio, we know ratios from our chapter on similarity. The ratio of the opposite leg to the adjacent leg is called the tangent ratio. So we can say the tangent of angle A is equal to the opposite leg divided by the length of the adjacent leg. Now, in shorthand, we write this as tan, T-A-N, just capital letter A for angle A, equals opposite, O-P-P, over adjacent. And even more shorthand, we can abbreviate this to the letters T and O and A, or TOA. And that's just a quick way to help you remember that tangent is opposite over adjacent. So the first thing that we're going to do is just find the tangent of the acute angles in a triangle. So in example 1, we see this triangle BDC, and so we have angle B at the top and angle C in the lower right-hand corner. Those are the two acute angles. Remember that acute means that it has a measure less than 90 degrees. So if we wanted to find the tangent of angle B, remember that tangent is equal to opposite over adjacent. So for angle B, the opposite side is 5. So put 5 in the numerator. And the adjacent side is 12. So very simply put, we can say the tangent of B equals 5 over 12. Okay, if we switch gears and we take a look at angle C in the lower right, well, now our perspective changes. Tangent is still equal to the ratio of the opposite side over the adjacent side, but for the angle that I just marked in red, angle C, 12 is the opposite side. So let's just erase that. And now write opposite here. And this side marked with 5 is the adjacent side to that angle. So we would say the tangent of angle C is equal to 12 over 5. And again, we can do shorthand and say tangent of B is 12 over 5. And we're all finished. So again, when you go to label the opposite side and the adjacent side, it's really dependent on which angle you're referring to in the triangle. Okay, every angle has a specific value associated with its tangent. So if you looked at a trig table, and we're going to take a look at a trig table in class, you're going to have a table full of numbers, and every angle measure would have a value under the tangent column. But we can also use this on a scientific calculator. We can look things up using our calculator. So you need a scientific calculator or you need a smartphone, and your teachers can show you how to use your smartphone for your homework. Okay, so if you're in class, you're going to grab one of the blue scientific calculators or a graphing calculator, and all we're going to do is turn your calculator on, press the tangent key, it just says TAN, and then you're going to type in the number 30 and hit enter. And you'll see a bunch of decimals come up, and it says round decimals to the nearest 10,000th. So that means that we have to round to 4 decimal places. So the tangent of 30 degrees would be rounded to 0.5774. And again, we can also look this up on a table. Okay, try the next one. Tangent 45. We get exactly 1. And we'll talk later about why the tangent of 45 degrees is 1. This is a great way to see if your calculator is set in the right mode. There are a few different ways to measure angles, and we're measuring angles in degrees. You have to make sure your calculator is set to measure angles in degrees as well. So if you can remember this, that the tangent of 45 is 1, that's a great way to check and see if your calculator is set to the right mode. If you type tangent of 45 and you pressed enter and you got a number other than 1, make sure that you ask your teacher how to reset your calculator so that it is set for degrees. Okay, try the last one, tangent of 78 degrees. So press the tangent key, then the number 78, hit enter, and this rounded to 4 places would be 4.7046. So again, we're rounding to the nearest 10,000th, so that's 10th, 100th, 1000th, 10,000th. So we've learned how to solve for missing sides in triangles by using the Pythagorean theorem and also by using special right triangles, the 45-45 right triangle and the 30-60 right triangle. Now, what would you do if you were asked to solve for a missing side, like we are in example 3, but what would you do if you didn't have 2 sides so that you could use the Pythagorean theorem, or if your triangle wasn't a special right triangle? Well, that's where trig comes in. It says we can use the tangent ratio to solve for missing sides and angle measures in a triangle. So in example 3, it says find the value of x in each triangle below. Round answers to the nearest tenth. Okay, so check this out. We have this angle marked with 24 degrees, and since we go across the triangle to get to x, that has to be your opposite side. And this side is not the hypotenuse, it's a leg that helps to form the angle, so this has to be our adjacent side. So we're going to write a little trig equation that says the tangent of 24 degrees is equal to the ratio of the opposite side, which is x, over the adjacent side, which is 20. Okay, now we're set to solve for x. We're going to treat this as a proportion. Just put the tangent of 24 over 1. And we have a proportion. And remember that we cross multiply in order to solve a proportion. So we're going to take x times 1, we get x, and take 20 times the tangent of 24. Okay, you can go ahead to your calculator and type all this in at once. Just type it as 20 tangent 24, press enter, and then again the directions say round to the nearest tenth, so our answer would be rounded to 8.9. Now, I really hope that you're trying this on the calculator as we go. It'll really help you to understand the process of solving these trig equations. Okay, in our second case, we've got this angle of 35 degrees. So the side marked with 12 is the opposite side. And this side marked with x is the adjacent side. And notice, again, we're staying away from the hypotenuse. So our trig equation for this scenario would be a tangent of 35 degrees is equal to 12 over x. So it's different than the last one because we have x in the denominator. So this is going to take us 2 steps in order to solve for x. So first thing we would do is cross multiply. Go ahead and take x and multiply it by the tangent of 35. Put that x out in front. And we're going to set this equal to 1 times 12, which is 12. Okay, that was our first step. But notice we don't have it solved for x, so we need an additional step. So since x is being multiplied by the tangent of 35, we're going to undo that multiplication by dividing both sides by the tangent of 35. Now, we're still going to go to the calculator, but what you're going to type into your calculator this time is 12 divided by tangent of 35 degrees. Okay, so type it in 12 divided by tangent 35, hit enter, and round your answer to the nearest tenth, and you'll have 17.1. Okay, the final thing that we're going to do today is we're going to use trig, specifically the tangent ratio, to find the measure of angle A in each triangle. It says round answers to the nearest integer, so we're rounding to the nearest whole degree. Okay, so check out angle A in part A, and let's label those sides as being opposite and adjacent. Okay, so for angle A, 3 is the opposite side, 4 is the adjacent side, 5 is the hypotenuse, so we don't need it right now. So our equation would be the tangent of angle A, remember that's what we're trying to figure out, is equal to 3 divided by 4, opposite over adjacent. Okay, this is a little bit tricky to remember, but we're looking for an angle measure, and so we have to do what's called like a reverse lookup. It's like we know that the tangent is equal to 0.75, that's 3/4, and we're asking the calculator to figure out what angle measure has that value in the table for its tangent. So here's how you tell the calculator to do that. First write A for angle A equals tangent to the -1. We call that the inverse tangent of 3 divided by 4. So you're actually going to go to your calculator, but to get the tangent to the -1, you have to press the second key and then the tangent key. So second tangent and then type in 3 divided by 4 and hit enter. Now when you see this decimal, you're going to see 36.8698 and so on. Remember the directions say round to the nearest integer. So we're going to say that angle A, the measure of angle A, is 37 degrees. Okay, let's try another one. Okay, in the second case, angle A is down here in the lower left-hand corner. So if we travel across the triangle, 8 square root of 3 is the opposite side, and 8 is the adjacent side. Again, 16 would be the hypotenuse, and we don't work with the hypotenuse when we're dealing with tangent. Okay, so we would say the tangent of angle A is equal to 8 square root of 3 divided by 8. Now check out that fraction. We can reduce it and say the tangent of A is equal to the square root of 3 because the 8s would divide out. So here's where we want to tell the calculator that we need to look up an angle measure. So we'll say A, or angle A, is equal to the inverse tangent of the square root of 3. So let's go to the calculator now. So press second and tangent, making sure you cleared out any old calculations. So press second tangent and then type in the square root of 3. Press enter, and we have 60 degrees. Now, if you're a little surprised by that, go back and take another look at the triangle. I set it up so it was a special right triangle. 8 square root of 3, and 16. You see that relationship? 8 times 2 gives you 16, so the hypotenuse is twice as long as the short leg. So if we call the short leg x, this would be 2x. And check it out, this side is x square root of 3. So really we didn't need trig to figure out that angle if you're really observant and looking at those sides, but it's nice to know that we could use trig as a backup. Okay, good luck on the CYU and the homework. As always, speak up when you have some questions.